Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, my name is محمد الأحمد and today I will be giving you an introduction to CNC machining. This presentation is based on what we learned in class that was taught by the Professor Faisal Alayan. So let's start by giving you a brief history of CNC machining. So CNC machining has a long history that started in the 40s and 50s of the 20th century, and it started with numerical control using punched tapes. After the introduction of microcontrollers, we've had our first CNC machine in the 1970s. Since the 1980s, we have seen rapid progress, including automation and multi-axis machining, achieving up to 5 axes. Today, it's a huge global market worth $88 billion. That's in 2023. And that's the last value you could see online. And the projected and expected value is approaching $128 billion in 2030. So yeah, it's a huge market. So what is CNC machining? It is a subtractive manufacturing process, which means it removes material from a solid block to create a final part. The entire process is controlled by a computer. It's very precise and can make parts over and over again with the same accuracy. And that's what human cannot do, yani, repeatably. And that's a difference in it being a subtractive, unlike the 3D printing and other additive processes. As you can see, CNC machining follows a clear workflow. First, we use a CAD software to design the 3D model. We've been taught SolidWorks here in our college. You can use other softwares as well. One of the most famous ones is Fusion 360. After that, we use a CAM, which will generate our G-code from the model we have. After that, we just set up the machine with the tools and materials, and then we run the program, and the machine just starts cutting the parts miraculously. Finally, we check and finish the part of the product. Is it finished? Is the finish to our liking? If it is, then we just move to other processes. A CNC machine has several main components. You can think of the control unit like the brain. It reads the G code, and through the control unit, we can control it manually through the software. Then we have the drive system, which moves the machine's axis using the motors. Some machines have 3 axes, some have 4 and 5 even. This gives you an insane control over the tool that cuts, and you can get better results. Then we have the cutting tools, which removes the materials. You can see, we can put it here like in a milling machine. Sometimes there is a drill bit, sometimes there is for the mill. We have a lot of tools we can put. And through the chuck, there is even a tool selection and tool change programs even. So it can do a lot of things just by providing the program. And then we have the machine bed. Here we will put the workpiece. We make sure it's in place. We configure it properly with the home, with the data and everything. There are different types of CNC machines for different jobs. So CNC milling machines, they cut 3D shapes from solid blocks. It's used a lot in automotive and aerospace and every place. Then we have the lathe. This is different a little bit from the milling. The milling, we have the piece set on the bed and the cutting tool coming to it and cutting. For the lathe, it's the other way around. We have the tool churning and the cutting piece coming to it, and this one is turning. Then we get our intended piece. Mostly it's used for parts like shafts and can be even used for threading, outer ones mainly. Then there is the CNC drilling for making accurate and precise holes, and can be even used for PCBs, for the circuit boards, or even in engines as well. We can use the drilling. We have CNC laser cutting, which is another operation and type of operation for the CNC. It can cut and engrave materials like wood, plastic, or sheet metals. So CNC machining is used almost in every major today because of its ability to produce parts with high precision and consistency, whether it's for transportation, healthcare, electronics, or general manufacturing. CNC technology plays a key role in creating everything from small detailed components to large structural parts. Its flexibility in handling different materials and designs make it a valuable tool in modern production environments. You can get repeatable, precise products with marginal error or tolerance. So it is the best thing that happened for the industries nowadays. To conclude, CNC machining has completely changed the game and how we make things. It's fast, accurate, and flexible. And the technology continues to grow, especially with things like AI and smart manufacturing. The future will also focus more on sustainable methods, which is really exciting, especially for a subtractive method. What I forgot to even mention is that even though it's a subtractive method, nowadays many companies and use different approaches for recycling the material and reusing it. So yeah, it's even becoming environmentally friendly. Thanks a lot for hearing me out. I hope you had a good time.